Okay. Another feature that we are going to kind of practice is the helical feature. Let me show you an example. So the output of this feature would be a 3D curve. For example, let's say I would go off of the front plane and I draw a circle. And then let's say diameter is 10, and if I go out of the sketch, ISO view, if I wanted to create a curve, a 3D curve that would go after essentially would shape like a helix, like a spring. If I select this and then in the feature I'm going to curve, and then there is a helix and a spiral command. And then there are some features that you can select. Essentially, you can define by the pitch and revolution. You can define by the height, which that the height means the overall span. And then let's pick up this one, height and revolution. Let's say I wanted this go over 100 millimeter, and the number of the revolution is 10. You will see that it creates a helical curve across that. So each of, from one turn is the pitch, that how it's going to travel. So you can define by either combination of the two combination of pitch, revolution, or height. And then the other point is, let's say pitch and revolution. I wanted the pitch would be 10, it would be 10 because 100 millimeter. But if I select a different pitch, it would be like a shorter spring, so on and so forth. So you can go really creative how many you can do that. But if I pick the height and revolution, let's say is a 50, and then I find the curve, essentially I would have like a different type of that. Then if I keep this one, let's say I have this like a sort of helical. Then if I go back to the same plane that I created that, which would be the front plane, you will see the start of that was here, right? So if I create any shape and then keep that as a starting on the same point, if I select that corner, if I select this one, let's say any shape, going to parallel, essentially I can define it as this one be horizontal, and any curve that is located on this point. Then having this profile and this spiral curve, I can create a feature which is called sweep bus. So if I go to the sweep bus, the profile is already selected, so it's asking for a profile and what is the guide curve. So hit OK. You will see that this, let's hide this one for a second. You will see that this like a kind of like a rectangle is going all over that. And if I wanted to, the shape is kind of like not that rectangle was supposed to be, but the point is I can go here and select how the guide curve would go around that. But so I can say if the profile should be that, or it should be constant, or the profile twist, how it's supposed to be. But essentially the idea is, I show the curve one more time, that would be the helical that's going there, and it's because it's not perfectly parallel to this one, it's gonna shift a little bit, and you see that the curve is going and following this curve. And now you can kind of define how the tangency would look like. For example, I would say start with path to tangent, and you can define curvature display if you wanted to see how the curvature look like. There are other options that you can go over with. So that was the idea of the pitch and helix. And now we are going to practice a little complicated task, the part that we were going to try on it. So let's save this. And now we would like to try a little more advanced, more in-depth example of the features that we've learned so far on a fairly, I would say, a little complicated part. It's not as scary, but it's a little involved into using multiple features here. So I call it a cranky, and let's divide it into some smaller kind of like approach. How do we have to model it? The way that I see it, you will see that this is like a tapered boss extrude here, and the reason it's tapered is like a 2 degrees tapered inward with 15 millimeter diameter, and then there is two cuts with representing the key around here, and then there is at the end of this key there is a sort of like a very small like an oval that we can do that by the loft feature. It sounds like this profile is going to emerge and transition to the smaller profile at the end of this like a cranky. So the more kind of complicated part is to we have to model this key, which should not be that much difficult because the profile is already given here. Here's the profile for each of this key, and then how many key we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 keys around it. Sounds like they are equally spaced. It's not given, but we can assume that. And then the most important part of that feature that we have to be careful is the node that is given here, that essentially that's address how the guide curve for that helical curve should be defined, which according to the node here is a quarter turn across 200 millimeter pitch. So let's start modeling that. I'll keep it here. Let's go back to SolidWorks. I'm going to bring apart and save it as practice. I believe it was 5. Okay. So starting from that, you will see that this part we can start by this boss extrude. Let's say this is start from the top plane, and we can go in, or we can in any plane we can do that, but it's at 15 millimeter. So I would model it off of let's say here, off of the front plane. Why not? So circle, and the diameter was it's millimeter here, so that would be 15 millimeter. And it sounds like from this plane all over to here, not all over to top here, that would be the boss, would be 30 millimeter boss extrude over 2 degrees tapered. So coming here, I would like to go with a different direction, essentially with blind going in that direction. I want to, you know, that would be the the handheld of the key, and this is like the sweep boss, this direction. But you can, you know, it's not must have, but you can select any other plane that you're more comfortable with. Okay, 30 millimeter, and then here is the one that you need to, when you trying to define a draft, and this is 2 degrees. You see that going inward, if you wanted to draft outward, it would be like this, but so 2 degrees, and then that would be the part that you have for kind of like a lat taper. Okay, so the boss extrude has been modeled here. Now there is 2 cuts off of this boss extrude with those features that we are going to do that. It sounds like it's 10 and then the radius of 4. So if I'm coming here, I would select a plane like right plane, for example. And I know that those cut feature are symmetrical, so I will create a line for construction, infinite path, and put it horizontal here. So this tells me, if I wanted to go back to where I was for that. Okay. So the cut is right over here, and I think some dimension is not giving here what is the height of this cut, but we can go like we can define it in a way that is matching. If some of the information is not given, you can I will give it throughout this example to show how the cut should look like. So I'm going to cut it like over here, and then with some degrees, and then there is a curve going all over here, and there's another line here, and it's given here. So this portion is 10, and this radius is 4. So I think, so you see that the one with the center is 8, so I don't think we need that height. We can define it with this one. So you can either select here and say 4, but if you shift it here, SolidWorks will give you the diameter. So that would be 8. So yeah, you didn't need to have any height of that. But one thing is important about this curve. You have to make sure the curve goes all the way here, meaning that the center of the curve and this line should be exactly on the same axis. If you cannot define it properly, it's better to stop it and then add more relations to that. Okay, so it's here. Then I can select this one for the mirror, and I mirror the entities here, and just the feature that the sketch entities that I would like to mirror, and then I will select this one, this line, and then it would mirror here. Sketch is fully defined. Going back out, and we are going to define a extrude cut of this profile, and I would select throughout both, and here's the key. Has been defined, nice and easy. So other feature are the loft that I can define it here. So in order to do that, if I'm going back, the loft is 2 millimeter away. The sketch is 2 millimeter away from this one. So I can select this part, go and define it with 2 millimeter around here, and then going back to this. So the sketch would tell me it has 2 millimeter offset with the cutout of 4 millimeter. So one easy way to doing that is to essentially I can offset this entity to be 2 millimeter, and I would like to be reverse. So here and here are 2 millimeter. Would it give it to me? Oh, maybe they have a problem with that. So let's try it one more time. Offset of 2 millimeter here, reverse. Sometimes SolidWorks would have difficulty into offsetting multiple parts, multiple sketch entities. So you have to be a little more patient to define it by more steps. So, and then there is a line here, there's another line here. This says how much is the distance between them. It's 5 and 2, which might not be the one that it says here. It was saying this is 4. Okay, so we have to delete this and delete this. So what I'm going to do, I'm going to define a center line, horizontal